Hey everyone, my name is Joshua Parris. I am a junior attending the University of the Virgin Islands St. Croix campus. I will be talking about the summer research project that I did. For 6 weeks, I had the opportunity of working with Dr. Dario Carbon on an informative and interesting project under the ECS program. For this project, I looked for transient sources in the dataset that I received. Transient sources are sources that are momentary. They also do not have a constant flux. Sources in the sky at night that you may observe with a telescope will have a constant flux. With transient, it varies. The flux changes over a period of time. Flux is the brightness of the source. With the flux, we'll be able to find transient sources in our dataset. We will also have to include the noise of the image. Noise is not the sound in the radio or a car on the highway. Noise affects the true measurement of the flux. Among these transient sources, I've only focused on transient sources using radio waves. Our goal was to constrain the rate of these transient sources. We wanted to constrain the rate because it is very important into understanding what causes the unknown of these astrophysical events. The methods I used were LOFAR, which is a radio telescope that allowed us to search for transients. I also used DS9, which is a computer program. DS9, with DS9, the images we got from the telescope, we organized them into 4 different fields based on the coordinates we got from DS9. DS9 allowed us to get the flux, noise, and coordinates of the sources. Our next step was to use a computer programming language called Python. Python allowed us to create light curves that will allow us to see how the flux changes over a period of time for these sources. Over the 6 weeks, we only focused on 4 of the brightest sources that we could identify in the first row. Based on the sources analyzed, these are the light curves that I built. The number I got also verifies what these sources are. The number in each graph is the slope of the line of best fit. The fact that this number is close to 0 verifies that the best fit is close to a horizontal line, which represents that the light curves of a constant source. The challenges that I faced were getting used to Python and grasping the new information. Using Python was quite challenging, and also grasping the new information. But with the help of Dr. Dario Carbon, I was able to get used to locating errors in Python and tips and tricks that I could use while programming. And also, I learned a lot of information about radio astronomy. So these are my results. There weren't any transients found, but we were able to set an upper limit to the transient surface density. Transient surface density is a measure of how many transient sources you can expect to observe in any 1 square degree in the sky at any moment. According to the method described in Carbon et al., the upper limit that I set depends on the number of images used, assuming that all images have the same field of view and are from the same part in the sky. After eliminating the noisiest image and recalculating until there were 2 images left, I got the upper limit. The limit we could put on these sources that are not brighter than 2.5 Janskis is lower than 0.002 degrees minus 2. And that is the end of my presentations. Thank you for your time.